Hello friends, I am Shlok Kulkarni. I welcome you all to my YouTube channel. Today we are going to continue with a series of quiz lectures in which we will solve random 8 questions from various topics of MET, REGS, NAV and Tech. Hope you all are doing well and all your preparation is going smoothly, time to time, consistent. So let's start with our question number 1. The correct statement of all these four options is what? In first statement, we have that static pressure on the upper surface of the wing is greater than that on the lower surface. The static pressure on the upper surface of the wing is lower than that on the lower surface. The next two options talk the same thing but about the pitot pressure. So let's first see the lift generation of a wing. To understand this question, we will have to see the lift generation of a wing. To understand that, first let's draw an aerofoil. Okay, so this is your aerofoil. What is an airfoil? It is a cross section of the real wing. On this airfoil we have this camber, that is the curvature of the wing is called camber. Then we will have relative airflow coming from the front. Then we will have one branch of airflow flowing over the top surface of the wing, and then it is getting a downward push or downward acceleration, and on this side of the wing, that is the trailing edge of the wing. The other branch of the airflow will go below the surface of the wing, and in the same manner it will also get a downward acceleration. So this is the basic diagram for understanding the lift generation of a wing. Next we have Bernoulli's theorem. You all have heard about this Bernoulli's theorem at school. What does this theorem state? It states that the total energy of a system remains constant. This is what the Bernoulli's theorem states. The total energy of a particular system remains constant. That means what? If there is an increase in one element of a system, it is followed by a decrease in another element of a system. So that means there should be a compensation between two things in that system. An increase in one results in a decrease in another. A decrease in one results in an increase in another. So that is what your Bernoulli's theorem states. Now this Bernoulli's theorem is going to be used now to understand lift generation of a wing. Now when this airflow flows over the upper surface of the wing, it accelerates in velocity. Its velocity accelerates. And this velocity accelerates because of the curvature of the wing or because of the positive camber of the wing. So why positive camber? If the curvature is on the top surface of the wing, meaning this is your chord line. If the curvature is above the chord line, it is called positive camber. If the curvature of the wing is below the chord line, it is called a negative camber. In this example, we will see positive camber, means the wing is curved from above, above the chord line. Now when this airflow follows the upper surface of the wing, its velocity increases. Now when velocity increases, there should be another element or something else over here that should decrease as a consequence of increase in velocity. So following Bernoulli's theorem, an increase in one element will result in a decrease in another element, right? So here the increase in velocity will result in a decrease in pressure. Now let's look at the bottom surface of the wing. The same Bernoulli's theorem will be applied here on this surface of the wing. That is, when the branch of airflow follows the lower surface of the wing, its velocity decreases compared to the velocity on the upper surface of the wing. The velocity here will be decreased. As a consequence of it, following Bernoulli's theorem, an increase in one element should be followed by a decrease in another element. So if velocity has increased, something else should decrease. So over here, something else should increase. Correction. Pressure will increase or pressure increases. Pressure increases. Okay. So therefore, we have a low pressure on the top surface of the wing. We have high pressure on the bottom surface of the wing. Okay, so this is the full application of Bernoulli's theorem to the lift generation of a wing. Now we always know that in atmosphere that the flow is always from high to low. Okay, from a high level to a low level. So over here we have low pressure on the top, high pressure below the wing. Okay, and this pressure, what pressure are we talking about? We are talking about atmospheric pressure. Now this atmospheric pressure can also be called as static pressure. We all know that as I sit here, or if anybody, as I sit here, there is pressure acting on my body. That pressure is called atmospheric pressure. This pressure is always available in the atmosphere. Whether you sit, you stand, you walk, you run, you crawl, there will be pressure acting on your body called atmospheric pressure, also known as static pressure. So this pressure that we are talking about over the wing and under the wing is atmospheric pressure or static pressure, always available in the atmosphere. Now next thing, we have low pressure on the top, high pressure below. Flow is always from high to low. So due to lower pressure existing on the top, this wing surface, this wing will be pulled in the upward direction, okay, towards the direction of low pressure, and as a result lift is generated. As a consequence of that, or as a result of that, lift is generated. So high to low, this wing will be pulled upward, and that upward force is nothing but a lift force. Okay, so this is one way of explaining the generation of lift using Bernoulli's theorem. There is another way, which is using Newton's third law of motion. As of now, let's let's limit ourselves to this question. So the correct statement here will be the static pressure on the upper surface of the wing is lower than the pressure on the lower surface of the wing. Pitot pressure, as mentioned in option C and option D, are irrelevant. Pitot pressure is what you encounter when studying airspeed indicator chapter. Question number 2. So like you see here, high velocity of airflow and therefore low pressure, low velocity airflow, high pressure. Direction of resultant force will be upward. As a result, the wing will be pulled upward, and that upward force is the lift which sustains aircraft in flight. Question number 2. Without readjusting the altimeter setting, it will underread under what circumstances? Okay, when will it underread? So we have done altimetry questions. If you have not watched those videos, do watch that playlist of solved questions, Oxford Altimetry. I have made a separate playlist for that. Also, I have made a knowledge series playlist for meteorology. In that, I have explained in detail, thoroughly, the errors of altimeter, specifically barometric error and temperature error. So do watch those videos, do solve the questions of altimetry that I have done, and then you will be thorough and confident in this concept of altimetry error. When does an altimeter underread? When will it give an overreading indication? Okay, so coming back to this question, if you don't reset your altimeter setting, it underreads under two circumstances. Okay, so underread means what? Your true altitude is more than the altitude that is being indicated. Now your true altitude is more than your indicated altitude in two circumstances. First, during temperatures warmer than ISA, and second, during high pressure. If there are warmer temperatures in that area, warmer than ISA, remember this, or high pressure exists, your true altitude will be more than indicated altitude, or your indicated altitude will be less than true altitude. So under reading means what? To under read means to indicate less than the real altitude. So the correct answer will be when you are flying from low pressure to high pressure. Either of these two possibilities should exist in your options. So we have high pressure, that you go to a high pressure area, and as a result of that your indicated altitude decreases. In a straight and level flight, the flight path and relative airflow, what is the relation between them? So look at this figure. This is your straight and level flight. Okay, over here aircraft is flying straight. Let's say this is your north direction, this is your east direction, this is your west direction, and this is your south direction. Okay, so as you can see over here, this case straight and level flight, what you see, your aircraft is flying westerly direction and it is flying straight and level, means not a climbing attitude, not a descending attitude, not a turning attitude, just straight and level. Okay, in line with the horizon. So what will happen as a consequence of that flight path? There will be a generation of relative airflow which will be coming from the opposite direction and parallel to your flight path. So if your aircraft is going westerly, the wind or relative airflow will come from west, okay, and it will go towards east. So opposite direction, the aircraft is going towards west, this airflow is going towards east, and the airflow is parallel to your flight path. It is parallel to your flight path. Therefore, the answer to this question will be the flight path and your relative airflow will be parallel and opposite in direction. Both of them will be parallel and opposite in direction. When you are descending, now in this case, figure number 2, your aircraft is descending, okay, and it is going in the direction of southwest. As a result of that, it will get a wind which is going towards northeast, means coming from southwest, going towards northeast. So as a result of that, this relative airflow will be in opposite direction and again parallel to the flight path. Same case applied to the climbing scenario. It's climbing in the northwest direction. The wind will be coming from northwest going towards southeast. Okay, opposite direction and parallel. Let's go to question number 4. To put L, the letter or the alphabet L, that is Lima in radio telephony, in your wake turbulence category box of a flight plan, what maximum weight must aircraft have? For that you must remember this table. So every aeroplane is classified depending on its weight into light, medium and heavy. This light, medium, heavy, okay, this light, medium, heavy are relevant to wake turbulence category. Okay, relevant to wake turbulence category. So when you want to classify aircraft, depending on the wake turbulence category, you can classify them into 3 types: a light aeroplane, medium aeroplane, heavy aeroplane and super heavy. So for an aeroplane to be light with the perspective of a wake turbulence category, its maximum takeoff weight, okay, remember this word, it is maximum takeoff weight, not regulated takeoff weight or not maximum payload, not maximum zero fuel weight, maximum landing weight. So remember this word, maximum takeoff weight, so that it should be between for a light category, your weight should be less than, maximum takeoff weight to be less than 7,000 kilograms. Okay, kilograms. If the options contain pounds, SI unit, a unit of pound, you can convert kilogram into pound using your CX3. For medium category aircraft, the weight should lie between 7,000 kg and 1,36,000 kg. For a heavy aircraft, its weight should be equal to or more than 1,36,000 kg. For medium category, the weight is 7,000 and less than, okay, less than 1,36,000. For a heavy category, equal to or more than 1,36,000. Pay attention to that. A super heavy category is only for Airbus A380. Okay. So according to this question, for a lightweight turbulence category, the maximum weight limit that is given is 7,000 kilogram. Okay. Question number 5. Atmospheric pressure at 40,000 feet is how much? So I know this by heart. You also remember this. At 40,000 feet, atmospheric pressure will be 1/4 of pressure existing at mean sea level. So pressure existing at mean sea level is 1013. If you divide that, you will get approximately 250 hectopascals. You will get 250 hectopascals. So our correct answer will be option number C. For 40,000 feet, it is 1/4. Remember the value 4 and 4. Okay. Looking at this table, at 38,700 feet approximately, the pressure is 200 millibars, 200 hectopascal. So we are correct. At 40,000 feet, it is 250. Actually, at 40,000 feet, following this table, it should be less than 200, not 250. But fine, for the purpose of our question, it solves that question. PAPI is what? Papa Alpha Papa India. The full form of this PAPI is Precision Approach Path Indicator. Option number A. Now what is PAPI? PAPI are a row of 4 lights which are available to the left hand side of the runway. Okay, always to the left hand side of the runway, so that it is visible to an aircraft landing on that runway. It is useful to aircraft's landing. It is not useful for aircraft taking off or taxiing or any other maneuver. Only for aircraft coming in for approach and landing. So these are PAPI lights, Precision Approach Path Indicator. So precision. The meaning of precision here is that with the help of these PAPI lights, pilots can follow a standard glide slope of 3 degree. A glide slope of 3 degree. That means if this is your runway, okay, if this is your runway and there is a glide slope established on that runway of 3 degree, your aircraft will be able to follow a correct glide slope of 3 degree, okay, a correct glide slope of 3 degree down to the runway if it follows the guidance given by or the information given by this 4 white lights, a row of 4 white lights which are PAPI lights. Okay, so these lights behave in a certain way. So if you are correctly established on the glide slope and you are successfully maintaining that glide slope as you come down towards the runway, it will show a color combination of 2 lights. If you are above the glide slope or if you are diverting, if you are going away from the glide slope, it will show a new combination of 2 lights. If you are diverting or from the correct glide slope or you are going down below the correct glide slope, it will show another set of or another combination of 2 colors. Okay, so that information gives an idea to the pilot whether he's being able to successfully maintain the glide slope or is above it or below it. So we will check that out. Here is the case. This is the example number 1. Okay, over here you are able to see 2 red lights and 2 white lights. 2 red lights near the runway, 2 white lights away from it. So when you are coming in for landing and from far a distance you are able to see 2 red lights and 2 white lights, that means you are correctly on the glide slope at that moment of time, that place, that moment of time. Okay, so 2 red, 2 white means correctly established on the glide slope. Let's come to this example number 2. If you see 3 whites and 1 red, okay, 3 whites and 1 red, that means you are slightly above the glide slope. So for example, this is your runway and you are expected, so I'll draw that figure here. This is your runway and you are expected to maintain a 3-degree glide slope correctly. Okay, a correct 3-degree glide slope as you come down to the runway. And by chance, due to some negligence or pilot error, instead of being somewhere here correctly on the glide slope, you are little bit above it and you're coming down like this. Okay, so instead of coming down following this glide slope like this, okay, you are slightly above it and then you are coming down towards the runway. So in that case, automatically your lights, your PAPI lights will turn from or will change from 2 red, 2 whites to 3 white, 1 red. And when you are too high above the glide slope, you will see all white lights as you will see all lights as white in color, or you will see all lights white in color. So slightly above 3 whites, too high above the glide slope, 4 white lights. So same thing, let's come to this side of the diagram. When your aircraft is slightly below the glide slope, just in case as it was slightly above it, if your aircraft is slightly below the glide slope, you will see 3 reds and 1 white. And if it is too below the glide slope, you will see all lights as 4 red lights. Okay, so this is a simple thing that they often ask in Viva exams, simple Viva exams beginning from SPL, student pilot license, during your private check rides, commercial check rides, also maybe during airline interviews. This is a probable question that can be asked. Okay, and of course, practically when you fly, you go to different airports during your cross country flights, you will take help of PAPI lights when you're doing a VFR approach. When you're flying VFR, okay, maybe you are not an IFR pilot yet, you don't have IFR rating, so you are only limited to VFR. Okay, so in that case, the only option that you have is following a PAPI lights, a row of PAPI lights. You will definitely have in your cockpit in Cessna GPS, you will definitely have this OBS selector, in which if you tune your ILS frequency, it will behave like an ILS instrument and give you glide slope information, localizer information. That instrument you can use and still do an approach when under VFR. That is an option available. But PAPI lights is useful for VFR pilots. Whether they have an inboard radio navigation equipment like ILS or not, PAPI lights is all-weather gadget that is available at the airport, but you should be VFR. In case you are flying IFR, you don't need a PAPI lights as such. You are obviously flying under IFR, that means you will be using all your inboard navigation equipments, specifically ILS. Okay, if you're doing a precision approach, non-precision VOR or anything else. So let's come back to this question. So I hope you have understood this well. Now in this particular figure, you are able to see 2 red, 2 white. That means from the angle at which this picture is taken, that pilot at that point of time was on the correct glide slope. Next question number 8, last for today. Regulations require a pilot to level his wings. Okay, to level your wings means to, if you're turning your aircraft, to stop your turn and come back to normal straight and level attitude. Okay, wings level attitude. And initiate, that means start a maximum climb. Okay, maximum climb gradient means in a minimum distance you are able to climb higher and higher. So to cover maximum height in minimum distance means climb gradient. Okay, in minimum distance, maximum climb, that is called climb gradient. Okay, under what conditions? So this is related to ground proximity warning system. So whenever a ground proximity warning system issues you a warning, it is your duty to follow that warning, okay, immediately. So the correct way or the solution, the only available solutions in such situations will be to straighten your wings, level your wings, and just initiate a full power climb. Now we all know that ground proximity warning system. I have also covered this in some quiz. You will find that in many quizzes. I have put questions on ground proximity warning system. Also, I will do a detailed lecture on radio navigation ground proximity warning system, and that video is going to be there in this channel for your reference. Questions will be solved on this in detail also. As of now, a short introduction on this radio navigation equipment. This system is designed to prevent mishaps or accidents between your aircraft and the terrain below you, or any obstacle in front of you, or any obstacle in front of below your aircraft. Basically, we call this accident as CFIT, CFIT, controlled flight into terrain. That means everything is normal with your flight. Okay, it is under control. Okay, it is under your control. Everything is working perfectly. But due to some human error or pilot error, the flight has been collided or has collided with a mountain or any obstacle below in front of you. So that is called controlled flight into terrain. Basically, it's a crash. Okay, so the plane crashes. So to prevent that, we have onboard navigation equipment, which is ground proximity warning system. Whenever your aeroplane descends at a very high excessive rate, or whenever an aeroplane comes down towards the ground at a wrong configuration, in a wrong configuration, this system gives you alerts, warnings. If you're descending at a very high rate, alerts and warnings will be issued to you. Okay, if you descend just after takeoff, okay, instead of maintaining a rate of climb, your rate of climb has decreased. Okay, you will be again given an alert and a warning. So anytime when you are close to the ground and the system detects some abnormal tendency of aircraft to go towards the ground at a very fast speed, there will be an alert, there will be a warning followed by it if the alert has been ignored or not acted upon. So a ground proximity warning system has 7 modes. Every mode tells you different situations that can happen in a flight which can warrant a ground proximity warning system alert and warning. So first mode is excessive descent rate. Mode 2 is excessive terrain closure rate. You are going towards a terrain in front of you or just ahead of you at a very fast rate. Okay, this can happen when you don't reset your altimeter setting and you enter a cold area, colder than ISA air mass or a low pressure region. Okay, or you are a VFR pilot, you don't have an IFR rating, but due to some adventures you have entered IMC conditions and now you are unaware of the topography around you and you find yourself in mountainous areas, in clouds, in low visibility conditions, and you find yourself unsafe. Descent after takeoff. Again, after takeoff, you are expected to take off and maintain a climb to a higher altitude. If it happens that you happen to descend meaning if your rate of climb is expected to be 500 feet per minute, if that decreases to 400, 300, or 200, even that, an alert or warning will be generated. Okay, even system detects that because when you just take off, you are very close to the ground. There might be obstacles in front of you, towers, buildings. If you are taking off from a city, so that can be the case. Even when you come in for landing, and due to some abnormality, maybe due to some unstabilized approach or due to some abnormal situation at the airport, you decide to go around. Okay, even in go around procedure or a missed approach procedure, you are expected to maintain a safe line grade, a safe line attitude. Okay, at no point of time you can descend. Okay, climb means climb because when you come in for landing or approach, again you are very close to the ground. Okay, so you cannot afford to lose height at such a close level to the ground for safety reasons. VFR it's fine. Okay, you can look outside and evade an obstacle, but this all rules are made keeping in mind IMC conditions. In IMC conditions, you're totally flying in uh, unknown weather or atmosphere, meaning you cannot look outside because outside the visibility is zero. So basically, you're flying in oblivion. So that is why these rules are framed from the point of that, and it is very vital that you maintain your climb attitude or a specified rate of climb that the system tells you, and go to a safe altitude. So mode 5 is descent below glide slope. Again, just now we did PAPI lights. Whenever you go down below a glide slope beyond a certain limit, there will be a trigger warning, because when you go down below a glide slope, you are actually going down towards the ground. Again, an unsafe terrain clearance, unsafe for your life. So that is another mode. Mode 6 is situational awareness. In this, whenever you reach your minimums, your decision altitude, decision height, MDA, minimum descent altitude or minimum descent height, at that altitude, at that instant, the system will say minimums, meaning now is the time to make a decision whether to continue to land at that runway, or whether you want to initiate a missed approach and go to another airport, or you want to initiate a missed approach and make another second attempt and wait for weather conditions to enhance or improve. So mode 7 is wind shear. You can find ample amount of videos in YouTube when aircraft has come to land on the runway. It is just 50 feet, 40 feet above the runway, about to touch down, and there has been a gush of wind shear, and a sudden increase or decrease in wind speed, or a sudden reversal in wind direction, due to which all the calculations that pilot has made in his mind so as to maintain a crosswind correction, the speed of landing, and everything that he has calculated goes goes awry. That means everything goes in vain because of this wind shear, and in no way you can take the risk to land that aircraft on that runway in spite of wind shear. It is better if there is even some distance between you and your aircraft, between your aircraft and the runway, to go around at that moment of time. There have been instances you can watch in the YouTube when aircraft have done very hard landings because of this wind shear phenomenon at the 11th hour, at very last instant. Okay, so mode 7 GPWS also gives you wind shear information, and it's always recommended to go around whenever you get this warning. So the correct option over here will be, whenever you get uh, this so you are required to level your wings and initiate a climb gradient as soon as you receive GPWS warning, not an alert but a warning, and unless exception, you are in VMC conditions, you can look outside, visibility is good, cloud ceiling is very high, and you can decide and you can make a decision. Okay, you can see whether you are actually in danger or not in danger. Then and only then you can overlook a GPWS warning. Otherwise, follow the GPWS warning strictly. With this, we come to an end to this lecture, this quiz. I hope you have understood this lecture thoroughly. You have liked this lecture. You have learned something new today. And if you have done that, do hit the like button and let me know. Subscribe to this channel so you keep getting, or continue to get new updates, notifications, reminders, etc. And do share this channel as well as this video with everyone, so that everyone gets the benefit of this.